All right. So let's start the session today. So in yesterday we had discussed uh, we are doing classification of numbers. We'll continue from there only. So let me go to that slide directly. Uh, just wait. I'll move to the slide. Any doubts in whatever we had discussed last time? Tell me yes or no. No doubt. All right. So I think we are discussing about the properties of the even and odd numbers in the last session. So after even and odd, all right. So Siddharth is asking, can we? Okay, Siddharth, only the regular students can access those recordings. Only the regular students can access that recording. All right. Now, so we have discussed till question number 10. Now let's move to question number 11, or not question number 11. That is the concept of prime and composite number. Now remember, this is again one of the favorite topic of the CAT exam setters. They ask a lot of questions based on this particular concepts here. So we are going to spend a lot of time and I'm going to take a lot of variety of the questions based on prime and composite numbers to explain all the basic fundas here. Now, as you all know that prime number is a number which is divisible by 1 and the number itself here. Okay, divisible by the 1 and the number itself. So in other words, the prime number has exactly two factors. When I'm talking about two factors, I'm saying two positive factors, which is 1 and the number itself. Now, any integer, an integer other than 1 that cannot be written as a product of two integers, neither of which is equal to 1 or minus 1 is called a prime number. So you need to remember that prime number has exactly two factors and prime number can never be written as a product of two integers in which one of the none of the integer is 1. All right. Now, next thing here is a number which is not a prime, that is known as composite. And 1 is neither prime nor composite. That's a very important thing, that 1 is neither prime nor composite here. Now, few important property of the prime numbers. For that, I'm going to use the whiteboard. So let me come to the whiteboard here. All right. Now, the few important property of the prime and composite numbers is like from 1 to, can anyone tell me from 1 to 25? From 1 to 25, how many prime numbers are there? Can anyone tell me? From 1 to 25, how many prime numbers are there? No one. Okay. So from 1 to 25, a total of 9 prime numbers are there that you need to remember. All right. From 1 to 50, how many prime numbers are there? Can anyone tell me 1 to 50? 1 to 50, a total of 15 prime numbers are there. And from 1 to 100, how many prime numbers are there? 25. Okay. And from 1 to 1000, a total of 168 prime numbers are there. Okay. So you just need to remember these things here. 1 to 25, 9 prime numbers, 1 to 50, 15, and 1 to 125, and 1 to 1000 is 168 prime numbers. You can note it down on your notebook. Now, besides this, the few other things is that if I write down all the prime numbers, let's say starting from 2, okay, then 3, 5, 7, or maybe after 7, the next prime number is 11, 13, all right. Then I can say 17, then 19, then 23, or maybe 29, 31, and so on. Now, the most important thing here is that 2 is the only even prime number. 2 is the only even prime number. Except 2, all the prime numbers are always odd. Except 2, all the prime numbers are always odd here. So you just need to keep that thing in your mind. Now, after that, if you divide 5 by 6, what is the remainder? Can I say 5 is equal to nothing, but that is basically 6 into 1 minus 1. All right. 7 is what? If you divide 7 by 6, the remainder is 1. So 6 into 1 plus 1. 11 is what? 11 is nothing but 6 into 2 minus 1. 6 to the 12 minus 1. 13 is 6 to the 12 plus 1. All right. 17 is nothing but 6 threes are 18 minus 1. And 19 is nothing but 6 threes are 18 plus 1. 23 is 6 into 4 minus 1. And 29 is 6 into 5 minus 1. And 31 is nothing but 6 into 5 plus 1. So you need to remember that all the prime numbers, now it's a very important thing, that all the prime numbers except 2 and 3 can be written in the form of 6k plus minus 1. So all the prime number except 2 and 3 can be written in the form of 6k plus minus 1. But its reverse is not true, which means if the numbers are in the form of 6k plus minus 1, it's not necessarily a prime number. Okay, for example, if I say, let's say the number is 25. Now remember 25 is also this is in the form of 6 into 4 plus 1, but still it is not a prime number. So all the prime number can be written in the form of 6k plus minus 1, but all the numbers which are in the form of 6k plus minus 1 is not necessarily a prime. So that's a very, very important funda, and we are going to use this a lot in a lot of questions here. Is it clear to all of you? Can I move to the next slide now? Give me a response, all of you, please. Before I move to the next slide. Okay, that's great. Now, so you can also note down that remember few other things which are important here. How to identify whether a number is prime or not. Okay, CAT में इस पे भी waste questions आ चुके हैं. For example, if I need to identify whether 187 is a prime or not, can anyone tell me how to identify whether 187 is a prime or not? Now, to identify whether a number is prime or not, we always need to find out a square root, and I'm sure that you must have read it somewhere in 8th or 9th class. So first of all, find out its square root. Yes. Now, find out its square root lies in which range. Like I can say 11 square is 121, 12 square 144, 13 square and 14. Since root 187 lies between 13 and 14, so start dividing by all the prime numbers less than or equal to 13. Write down all the prime numbers less than or equal to 13. I can say 13, then 11, then I can say probably 7, then 5, and then 3 and 2. And start taking one by one. Now, is 187 divisible by 2? All of you give me a response. Is 187 divisible by 2? No. 187 is not divisible by 2. Is 187 divisible by 3? No. 187 is not divisible by 3. Is 187 divisible by 5? No. Is 187 divisible by 7? No. But is 187 divisible by 11? Yes. Yes. Why? Because 11 into 17 is equal to 187. So that's why 187 is not a prime number. That's why 187 is not a prime number. Okay, because it is divisible by 11. So whenever you need to find out whether the number is a prime or not, you always find out its square root and divide by all the prime numbers lesser than a square root. If it is divisible by any prime number which is lesser than a square root, then it is not a prime here. So whenever you need to check that whether n is a prime or not, so you can check for the factors, I'm writing down, check for the factors. If this number n has any factors between 1 and root n or root n to n. Now you can check it in any range. Either you check for the range 1 to root n or you can check in the range root n to n. If it has any factors between any of these two, the number will not be a prime. Why? Because prime number has no factors. Prime number का एक भी factor नहीं होता है, except 1. Okay. Now it doesn't matter. You can check either the first half or the last half. It totally depends upon you. But it's easy to check the first half, so that's why we always check it till root n. Is it clear to all of you? Can I move to the now next slide? All right. Okay. So let me move to the next slide here. How to check if a number is prime? Like I had already told you, that you always need to check for the number between 2 and square root of n. Take all the prime numbers. Either you check the first half or the last half. Okay. Now, try to solve this question, all of you. Please try to solve this question. Okay, what is the answer, guys? There are 5 prime numbers between such that P1 is less than P2, less than P3, less than P4, less than P5. So, which option is the correct one? Option 1, A, B, C, which option? Please tell me. Okay, that's right. Now remember, the sum of these 5 prime numbers, this P1 plus P2 plus P3 plus P4 plus P5, this 350. This 350 is an even number. Alright? And we know that except 2, all the prime numbers are odd. Now, let's say if I say P1 is an odd number, P2 is also an odd number, P3 is also an odd number, P4 is also an odd number, and P5 is also an odd number. So what is the sum of the 5 odd numbers? The sum of the 5 odd numbers will come out to be odd. We have discussed that. But we need the final result to be even. We need the final result to be even. So that is only possible if out of these 5 prime numbers, one of the prime number is an even prime number. Alright. And we know that there is only one even prime number, that is 2, which means that P1 is equal to 2 here. P1 cannot take any value except 2 because 2 is the only even prime number. So P1 की value 2 ले लूंगा यहाँ पे और एक ये even आ जाएगा. And then final sum will also comes out to be even here. So there is one value of P1. So P1 raised to power 5 has also got one value. So the answer is option A. That is 1. Is it clear to all of you? The answer will be option A. So can we move to the next question now? Great. So I'm moving to the next question. What about P2 as 5? Definitely we are not with Rahul. You can take P2 as 5, but we do not need to worry about P2 because the question is what is the value of P1 raised to power 5? So P2 कुछ भी हो इससे कुछ फर्क नहीं पड़ता है राहुल. P2 definitely 5 होगा या maybe 7 होगा. We need P2 to P5 will be an odd number. P2 to P5, all of them will be an odd number and that they will be prime. But we do not need to find out P2, P3, P4, P5 in that question. जब उसकी जरूरत पड़ेगी, then we can calculate. But here we do not need to find out. Is that clear? Okay. So I'm moving to the next question now. Tell me the answer of question number 12. It's again a very, very simple question. All right, that's right. The answer is obviously A. Using the same logic, that's right, sir. The answer is definitely option A here. Rahul took an odd number of prime numbers. Let's say he has taken 5 prime numbers. Same as the previous question, P1 plus P2 plus P3 plus P4 plus P5. 5 अगर प्राइम नंबर लेते हो और इसका सम क्या आ रहा है, इवन आ रहा है. इसका सम इवन तभी आ सकता है जब इसमें से आउट ऑफ वन ऑफ देम हैज टू बी एन इवन प्राइम नंबर. एक इवन होना चाहिए, बाकी के 4 क्या होंगे, फिर ऑड होंगे. देन ओनली द रिजल्ट विल बी इवन. सो द आंसर इज डेफिनेटली ऑप्शन ए. द नंबर इंक्लूड्स एन इवन नंबर. इज इट क्लियर टू ऑल ऑफ यू? ठीक है. सो दैट वाज वेरी वेरी सिंपल क्वेश्चन. नाउ सॉल्व क्वेश्चन नंबर 3. 13 all of you, not 3. Question number 13. Are primes, how many values can P take? How many values can P take? Okay. You do not need to find out the value of P. The question is how many values can P take? Okay. Now, let's see here. Remember one thing. First of all, let's try with 2 and 3. पहले तो hit and try करो. 2 and 3. If you take P as 2, okay, if you take P as 2, then P plus 2 is 4 and P plus 4 is 6. This is not possible. But what about 3? If you take P as 3, then 3 plus 2 is 5 and 3 plus 4 is 7. So 3, 5, 7, all the 3 numbers are prime. The question is, for how many values of P all the 3 numbers are prime? So 3 is definitely satisfying. But what about 3? After 3, there are a lot of prime numbers, so definitely we cannot take it out. See, we cannot go for hit and try. Let's try with 5, 7 and 11. But remember one thing, that after 2 and 3, each of the prime number can be written in the form of 6k plus minus 1. Okay. Each of the prime number can be written in the form of 6k plus minus 1. So let's start with that here. The first case. Let's say if I take the P as a 6k plus 1 here. If I take P as 6k plus 1, the value of P plus 2 will be comes out to be 6k plus 3, remember. And in 6k plus 3 is a common. Now this is 3 into 2k plus 1. Since this number is written as a product of 2 numbers, this number cannot be a prime. Okay, आगे check करने की जरूरत ही नहीं है. Because 6k plus 3 is 3 into something. 3 common आ जाएगा. So this number can never be prime. So this condition will not satisfy now. Similarly, rest other prime number can be written in the form of 6k minus 1. If you take P in the form of 6k minus 1, P plus 2 will 6k plus 1. Now remember, if it is 6k plus 1, it may be prime. It may be prime. क्योंकि prime number 6k plus 1 के form में होता है. Now put P equal to 6k minus 1. So P plus 4 will comes out to be 6k plus 3, which is 3 into 2k plus 1. Now again, since this is 3 into 2k plus 1, and we know that prime number can never be written as a product of 2 integers, so this will also not be a prime here. So now we can definitely say that there exists only one prime number. There exists only one prime number which will satisfy this condition. So answer is 1. That's a unique answer. This question was asked in CAT 2004. Is it clear to all of you? Okay. So always need to remember that except 2 and 3, all the prime numbers can be represented in the form of 6k plus minus 1. Okay. Now I'm moving to the next question. In case you have doubt, you can ask me. Solve this question. Yes, Sanchit, that's right. That's right. Okay, guys, now solve question number 14, all of you. Try to solve question number 14. Okay, so one of you is getting a problem regarding audio, so I hope that you have got the answer. Kushbu. Okay, now let's see. Let's discuss करते हैं इसे. First of all, try with 2 and 3. Is p equal to 2 is satisfying? Let's check. 2, 4 and 16. No, none of the three numbers are prime here. Okay, now let's try with 3. 3 plus 2 is 5 and 3 plus 14 is 17. Yes, all the three numbers are prime. All the three numbers are prime. Now remember, after 2 and 3, all the prime numbers can be represented in the form of 6k plus minus 1. So let's check with the form of 6k plus minus 1. Now, if p is in the form of 6k plus 1, remember, if p is in the form of 6k plus 1, so p plus 2 is what? 6k plus 3, which is 3 into 2k plus 1. Now, since it is a multiple of 3, so it cannot be a prime. So, any number prime, if the prime number is in the form of 6k plus minus 1 plus 1, it will not satisfy here. Now, check with the p equal to 6k minus 1. देखो अब यहाँ पे, when you put k equal to 6k minus 1, p plus 2 is equal to 6k plus 1. So it may be prime. It may be prime. Why? Because it is in the form of 6k plus 1. P plus 14 is 6k plus 13. It may be prime. Why? Because there is no factor which is common. So it may be prime. It may be prime. So we are not sure how many answers are possible, but definitely the answer is more than one. Now you can try with couple of the values just for explanation. If you take k equal to 1, you will get p equal to 5, then 7 and 19. Now remember 5, 7, 19, all the three numbers are prime. Similarly, if you take k equal to 3, you will get 17, 19, 31. All the three numbers are prime and they are satisfying the given condition. And so on. So for one thing we are sure the answer is more than 5. But how many values we cannot find out. Why? Because there is no limit on the prime number. How many prime numbers are there in this world? We even do not know that. Numbers का कोई end नहीं है. Okay. So we are not sure. So I will say the answer is more than 5. Is that clear to all of you now? In the previous question, we have got a fixed answer that 6k plus minus 1 was not satisfied. But here, the prime number which is in the form of 6k minus 1 may satisfy, remember. It may satisfy. So the answer is more than 5 values. So I'm moving to the next question. Since no one has asked any doubt, so I'm moving to the next question. I'm assuming that all of you had understood this particular question here. Okay. Now tell me the answer of this question, question number 15. Whether anyone has doubt? Any doubt, Lipsa? Because I am not seeing any doubt. Sanchit is saying zero values. Okay, Sanchit, we'll see for question number 15. What about the others? At least two, more than one. Okay, let's say P and P square plus 3P plus 1. P is 2. What will I get here? This is 2 square plus 3 into 2 plus 1. So 2 square is 4, 4 plus 6 is 10 plus 1, 11. So this is satisfying. 2 is a prime number as well as 11 is a prime number. Now let's take P equal to 3. So I get 3 square plus, I can say 3 into 3 plus 1. 9, 9 plus 9 is 18, 18 plus 1 is 19. So definitely this is also satisfying. Now after 2 and 3, all the prime numbers are in the form of 6k plus minus 1. So let's take in the form of 6k plus 1. So from here I'll get 6k plus 1 ka whole square. Alright, plus 3 into 6k plus 1 plus 1. That is 36k square plus 6 2s are 12k plus 1 plus 18k plus 3 plus 1. So this will coming out to be, this is 36k square plus 18 plus 12 is nothing but that is 30k. So 36k square plus 30k plus 5. Now remember this number 36 square plus 30k, this is a multiple of 6. So I can rewrite this as 6a plus 5. Now if it is 6a plus 5, it may be prime. Why? Because there is nothing common between these two. So this may be prime. So on the basis of this, आगे check करने की जरूरत ही नहीं है, but you can definitely say the answer is what? More than 2 or infinite, depending upon the options. Infinite answers are possible. Is it clear to all of you? Because 6a plus 5 may be prime. There is nothing common between them. Okay, so can we move to next question, question number 16? All right. Great, so I'm moving to next question. Now tell me the answer of this question, all of you. N is an integer for how many distinct values of n raised to power 4 minus 20n square plus 4 is a prime number. Try to solve question number 16, all of you. That here it is not given that n is a prime number. ये कहीं पे मैं mention नहीं है कि n is a prime number. N is any integer, and the question is for how many values of n this is the prime number. Now let's see here. Can I say this n raised to power 4 minus 20n square plus 4? Okay, this number can be written as n raised to power 4 minus 4n square plus 4 minus 16n square. Okay, minus 4 minus 16 will give me minus 20. All right. Now, this particular portion, this is a perfect square. Okay. This is what? This is in the form of n square minus 2 का whole square. A minus b के whole square के form में. And minus 16n square. I can rewrite 16n square as nothing but 4n का whole square. All right. 4n का whole square. Now, this number is in the form of a square minus b square. And we know that a square minus b square is always equal to a minus b into a plus b. So, this number can be written as n square minus 2 a minus b. So, minus 4n into n square minus 2 plus 4n. Now, since this number can be written as a product of two factors, now remember, I can say this is a into b. And since this number can be written as product of two factors, so it cannot be a prime. Why? Because prime number can never be written as a product of two different factors other than one. So we can say that it's a composite number because it can be written as a product of two numbers. So answer is definitely 0. Some of you have got it 0. So the answer is definitely 0. This is a composite number. For all the values of n, it will be always composite. Is it clear to all of you? Okay, can I move to the next question now? Please tell me yes or no. Siddharth, you will not get this value as 1. You can try. Why? Because remember this is what? N square plus 4n minus 2. So it will be always more than 1 in that case. Let's start putting the value of n equal to 1. Or n equal to 2, n equal to 3. वो कभी भी नहीं आएगा. Is that clear, Siddharth? And Francis? Okay, great. So let's move to the next question now. Solve this question. Question number 17. Yes, Harith, you can do that also. Try to solve question number 17, all of you. infinite, 1, okay, 0. Some of you are saying 0 also. We'll see. Akhil is saying n equal to 3. Okay, infinite. The question is how many values of n? Now, first of all, can you factorize this number? Can you factorize this number? Now, it's a cubic equation, though we'll discuss cubic equation in detail, but let's see. Okay, if you put n equal to 1, if you put substitute n equal to 1, what will I get here? 1 cube. 1 cube is 1 minus 8 plus 20 minus 13 is equal to 0. So definitely I can say n equal to 1 is the root of this equation. Yes or no? Iska root hai na? Because so I can rewrite this equation as what? Is a n minus 1. This expression is actually n minus 1 into. Okay, n minus 1 into क्या आएगा? Factorize करके. Can I write down directly instead of dividing it? On factorizing, it will comes out to be n minus 1 का whole is n minus 1 into n square minus 7n plus 13. Okay, n minus 1 into n square minus 7n plus 13. Alright. Now I need to see whether this number is a prime or not. Now, here you can see I have written down this number as a product of two factors. But if none of the factor is 1, then it may be, it is always a composite number. Let's put the different values of n here. Alright. If I substitute positive integers, put n equal to 1. At n equal to 1, I'll get 0. Okay. Now substitute n equal to 2, then I'll get 1 into. If you substitute n equal to 2, can anyone tell me what is its value on solving this? 1 into क्या आएगा? That's right, Shreya. 1 into 3. Now 1 into 3 is a prime number. So this is a prime. So this is satisfying here. After that, substitute n equal to 3. When you substitute n equal to 3, then you will get this expression as 2 into 1, which is equal to 2. Alright. This is also a prime. Remember, these two numbers are prime. Then substitute n equal to 4. When you put n equal to 4, you will get what? On putting n equal to 4, you will get this value as 3 into 1, which is equal to 3, which is again a prime number. So for n equal to 2 and n equal to 3 and n equal to 4, you are getting this as a prime number. But after that, if you put higher values, it will not be a prime. Why? Because in that case, none of the number will come out to be more than, okay, none of the number will be 1. If you put 5, you will get 4 into probably 5 square is 25. 25 minus 35 into 3 and so on. Because as you increase the number, it will keep on increasing. So none of the factors will be 1. So the answer for this question is that for 3 values, it will be prime. So the answer is 3 values. For 3 values of n, this number will be always a prime. Is it clear to all of you? For n equal to 2 and for n equal to 3 and for n equal to 4, this number is always a prime number. And after that, it will be always a composite number. Okay, great if it is clear. So, can we move to the next question? Akhil, no. What you are trying to say, that is wrong. You are saying second factor is quadratic, so only 2 solutions. You do not need to find out the number of solutions. Remember, cubic equation K, for any cubic equation, there will be always 3 solutions. That's not an issue. For any cubic equation, there is always a 3 solution if you substitute equal to 0. But the question is for how many values this is a prime. So your approach is wrong, Akhil. I hope that you got it, what I am trying to say. Okay, you are saying for one of the factor to be 1, but it's not necessary. It's not necessary कि वो 1 आएगा ही आएगा. Definitely it's a quadratic equation है, ये quadratic equation है, तो 2 values के लिए 1 आ सकता है, बट कोई जरूरी नहीं है कि वो आएगा ही आएगा 1. Is that clear now? हाँ. नहीं Harit, you cannot equate this equal to 0. The question is for how many positive integers this is a prime number. The question is not to find the number of solution. The question is for how many values this number is a prime number. तो ये प्राइम नंबर है तो 0 से कैसे इक्वेट कर सकते हो? ये एक प्राइम नंबर आना चाहिए. दैट इज द क्वेश्चन. n की कितने वैल्यूज के लिए? सो देयर आर 3 वैल्यूज. Am I audible? I'm not speaking anything, Sachin. Question is n equal to p plus k. मैं कुछ बोल ही नहीं रहा था. The question is n equal to p plus k, where p is the product of all prime numbers less than 89, and k is also lying in the range 2 to 88. So for how many values of k, n is always a prime? That is the question. So try to solve this question number 18, all of you. So 83 तक. 83, 84 is a prime, 85 is, sorry, 84 is composite, 85 is composite, 86, 87, 88, 89, all are composite here. And plus k. Alright, the question is for how many values of k it is a prime. Now remember one thing first of all. Few things जो strike करना चाहिए. This is an even number. N is a prime number. ये given है question में. N prime आना चाहिए. So which means k has to be odd. k cannot be an even number. This is the first thing which should strike in your mind. Alright, k is an odd number. Now, another thing after that, it says k can take any value. Now let's take k equal to 3. Now if I take k equal to 3, so remember this number is also a multiple of. Now remember this 2 into 3 into 5 into 7 into 11 into 83. So this is also a multiple of 3 and फिर उसमें 3 add कर रहा हूँ. So this entire number will become a 3 into a plus 1, which is a composite number. If you take k equal to 5, so remember this number यहाँ पे भी 5 आ रहा है. So this is also a multiple of 5. So 5a plus 5. 5a plus 5. Siddharth, any multiple of 2 is always an even number. Yes or no? Tell me. 2 का multiple even होता है या odd होता है? Even होता है ना? So that's why k p is an even number. और प्राइम नंबर हमेशा odd होते हैं. अब प्राइम नंबर हमेशा odd होते हैं, तो इवन में k odd होगा तभी तो ये नंबर प्राइम आएगा ना, अदरवाइज नहीं आ सकता है. Except 2, all the prime numbers are odd. Is that clear, Siddharth? Okay. Now, so like I saying, 5a plus 5, this will become a multiple of 5. Similarly, if you take any prime, any number, like if I take 7, then I'll get this is a multiple of 7 also. So this will be 7 into a plus 1 and so on. So if you take any values of k till 83, and remember that all the values, जितने भी composite numbers होते हैं ना, all the composite numbers are made up with the help of a prime number. For example, even if I take let's say 27, तो यहाँ पे 27 3 का multiple है, तो यहाँ 3a plus 27 आएगा ही आएगा. So this will be 3 into something, a plus 1 or a plus 9 and sort of thing. Okay. Alright. So none of the values will satisfy. Now the problem is after 83. If you take 84, so remember 84 is a multiple of 3. So 3a plus 84, 3 is a common. If you take 85, so 5 will be common. If I take 86, 86 में 43 will be common. If you take 87, 87 में the 87 is what? Is it a prime 87? No. 3 का 87 is 3 का multiple है, तो 3 common आ जाएगा. And 88 में तो 4 common आ जाएगा. So the answer is what? 0. Because this number will be always a multiple of certain number. So this can never be a prime number. So the answer is 0. Is that clear to all of you now? Great. So I'm moving to the next question. And next question में सबका answer आना चाहिए. Because next question is a quite easy one. Alright, solve this one now. अगर क्वेश्चन नंबर 18 समझ में आ गया तो 19 सबका आंसर आएगा. Yeah. Anupam is saying 5. Option 5. That's great. You all are right. The answer is 0. It's similar to previous question. Remember 2013 factorial plus 1 to 2013 factorial plus 2013 तक सब कुछ चेक करना है मुझे. तो सेम फंडा, नंबर क्या होंगे? 2013 factorial plus 2. ठीक है, 2013 factorial plus 3. Alright, 2013 factorial plus 4 and so on till 2013 factorial plus 2013. So what is happening in this case? In this case, 2 is a common. Remember, 2013 factorial is product of first 2013 numbers. In this case, this is 2 into something. इस केस में 3 कॉमन आ जाएगा, 3 into something. इस केस में 4 कॉमन आ जाएगा, 4 into something, and so on. In the last case, 2013 itself will come out होगी common. So 2013 into something. So here all the numbers are composite. Why? Because every number can be written as a product of two different numbers. So all of them are composite. So answer is definitely option 5, 0. Any doubt? Can we move to the next question? I need a response from everyone. Sushil, Divya, Kushbu, Megha, Neha, Satya Narayan, Aman. Alright, so I'm moving to the next question. Solve this question. Question number 20. Ankush, that's right. 2013 is not divisible by 4. But उसका इस क्वेश्चन से क्या लेना देना है? ये 2013 फैक्टोरियल है ना अंकुश? This is what 2013 फैक्टोरियल. यार फैक्टोरियल क्या होता है अंकुश? 1 into 2 into 3 into 4 into 2013. ठीक है ना? It's a product of first 2013 numbers. Alright. Solve question number 20, all of you. देखते हैं शुभम. Just wait. No, the simplest means when I was saying that the fraction is in its simplest form, it means there is nothing common between numerator and denominator. Like 1 by 2 is the simplest form, but 2 by 4 is not the simplest form. Why? Because 2 is common here. So the simplest form means that there should be nothing common between numerator and denominator. Okay, चलो check करते हैं. It says x plus 2 by 10. So first number is x plus 2 by 10. Alright. The second number is actually x plus 2. Just a minute. The second number is actually x plus 2 by 11 plus 1. 1 common आ जाएगा. Now you can see 11 1 is 11, 11 plus 2 is 30. Now x plus 26 by 12. 26 को 12 से divide करोगे, remainder 2 बचेगा. So the third number is x plus 12 2 is 24 plus 2. Alright. The third number is x plus 2 by 13. Sorry, इसमें 11 नहीं था, this was 12 plus 3. All right, and so on till last number. It will be comes out to be x plus 2 by 50 plus 40. All right. Now it says that the fraction must be in its simplest form. So here x plus 2 by 10 should be in the simplest form. X plus 2 by 11 simplest form में क्योंकि जो भी डिवाइड करना था मैं कर चुका हूँ. X plus 2 by 12 is in the simplest form. So x plus 2 by 13 is in the simplest form, and so on to x plus 2 by 15, which means that x plus 2, it cannot be a factor or a multiple of 10, 11, 12, 13 and anything till 50. X plus 2, it can neither be a factor as well as a multiple of 10 से लेके 50 तक कुछ भी नहीं होना चाहिए. So x plus 2 has to be greater than 50 and it has to be prime. Now why I'm saying prime? Because prime number can never be divisible by any other number. Now for example, if in the middle one, if I take x plus 2 as 51, for example, बीच में कहीं पे आएगा 17, x plus 2 by 17 भी आ जाएगा ना बीच में कहीं पे. So 51 by 17 is not the simplest form. So x plus 2 की वैल्यू 51 भी नहीं हो सकती है. Similarly, x plus 2 की वैल्यू 52 भी नहीं हो सकती है. Remember why? Because if you take x plus 2 as 52, in the middle somewhere you'll get x plus 2 by 26 also. So 52 by 26 is not the simplest form. All right, because 52 by 26 is 2. But can I take x plus 2 as 53? Yes. Why? Because 53 is a prime number. और प्राइम नंबर 10 से लेके 50 तक कुछ भी नहीं होगा. So x plus 2 is definitely not divisible by, I can take x plus 2 as a 53. Why? Because 53 by 10, 53 by 11, 53 by 12, 53 by 13 till 53 by 50. It is not divisible. 53 केवल 53 से divisible होगा. All right. So x plus 2 is equal to 53. So this implies x is equal to 51. So the answer is x equal to 51. Is it clear? Abhimanyu is saying x equal to 3 हुआ तो first fraction will not be in the simplest form. Yes, that's right, Abhimanyu. अगर x equal to 3 लूंगा तो 3 plus 2, 5 by 10. 5 by 10 is not the simplest form. That's right, Abhimanyu. So the correct answer is 51. Okay, Anupam is asking why didn't we see the x plus 2 less than 10? Okay, the simple reason is, Anupam, because anything which is less than 10, ठीक है, anything which is less than 10, वो 10 से 50 तक का कोई ना कोई फैक्टर ही होगा. Like if you take x plus 2 equal to 3, 3 is a factor of 12. If you take x plus 2 equal to 4, 4 is a factor of 12. If you take x plus 2 equal to 5, 5 is a factor of 10. तो 5 by 10 cancel out हो जाएगा. क्योंकि रेंज बहुत ही स्मॉल है ना, 10 से 50, these are 40 consecutive numbers. These are 40 consecutive numbers. So anything less than 10 will be always a factor of all the numbers from 10 to 50. Now this question was asked in JMET. Now what is the JMET? अब तो JMET scrap हो चुका है. JMET is Joint Management Entrance Test for the IITs. पहले IITs में MBA करने के लिए एक अलग एंट्रेंस होता था, that is known as JMET. But nowadays IITs are accepting a score of CAT. So I hope that this is clear. Can we move to the next question? Okay, great. So I'm moving to next question, that is question number 21. In case if you have any doubts, anyone, you can always ask me via chat. Okay, solve question number 21. This was asked in CAT 2006. That's a pretty easy question. नो श्रेया, ट्राई करो फिर से. It says the number of employees is a prime number and is less than 30. The ratio of the number of employees who are graduates and above to that of employees who are not can possibly be. Okay. So basically, the sum, the total number of employees prime number. So in this case, the total number of prime number is 189. Okay, 189. 101. But 189 is a multiple of 3. This is 3 into 3 6 are 63. So it cannot be prime. So option A cannot be answer. Second case where this is 187. 187 is 17 into 11. 187 is 17 into 11. So again, it is not a prime number. Next one is 111 plus 110, which is 221. 221 भी किसी का मल्टीपल है. किसका मल्टीपल है 221? 7 का नहीं है, 5 का नहीं है, 13. 221 is also a multiple of any number. Just a minute. 13 का है शायद. पक्का. 13 ones are 13. 7 का है. That's right. 7 threes are 21. नहीं यार, 7 का भी नहीं है. 13 7 का भी नहीं है. But just a minute. I think 17 का होगा. Yes. 17 into 17 threes are 17 ones are 17. 17 threes are 51. 17 into 13, I think. Yes. 17 into 13. 85 plus 98. 85 plus 98 is again 183. 183 is a multiple of 3 itself. 3 into 61. So definitely the answer is option E. So the correct answer is option E. So this was a very, very simple question. But you know, every year CAT में ऐसे questions आते हैं. But the challenge is how to identify those easier questions. That is the challenge for most of us. In those 70 minutes, so 20 में से 4-5 sitters ढूंढना वही tough होता है. All right, so I'm moving to the next question now. I hope that this is clear. Solve this one. This is also from CAT papers. Anupam, no. Remember, why I'm saying this one 6k plus 1? All the prime numbers can be written in the form of 6k plus 1. But if the number is in the form of 6k plus 1, it's not necessarily a prime. Reverse is not true. ठीक है? हाँ, उससे कुछ ऑप्शन डिलीट कर सकते हो, but not always. Now solve question number 22. This was asked in CAT 2003. Okay, that's right. Most of you are saying D. The D is the correct answer. X is a prime number and Y is a composite. So Y minus X cannot be an even integer. It can be an even integer. Like if I take Y की value 6 ले लेता हूँ और X की value 2 ले लेता हूँ, तो 6 minus 2 is 4, which is an even number. So option A cannot be the answer. दिल्ली में बहुत ठंड है सुबह. Now X Y cannot be an even integer. No, it can be even, like 2 into 6 ही ले लो is 12. This is an even number. Now X plus Y by X. So X plus Y by X is equal to nothing but 1 plus Y by X. It cannot be an even integer. I think it can be an even integer if you take Y is equal to 6, X equal to 2. So I'll take this as a 4. So this can be also an even integer. So answer is definitely option number 4, D. None of the above statement is true. All the statement A, B, C are false statement. Okay, this was a very easy question. Can I move to next question? Question number 23. Okay, solve this. This is also from CAT 2003. Okay, that's right. आंसर इज ऑप्शन नंबर 4. अभी स्टार्टिंग में डिस्कस किया था मैंने, ठीक है, दैट 1 to root n or root n to n. If there is any factor between 1 to root n, if there is any factor, then this number is not a prime. Then it will be always a composite integer. I have discussed this in the very beginning of this today's lecture. Because if there is any factor between 1 to root n, then this number will be always a composite number. Or if there is a factor between root to n to n, then this will be also a composite integer. Otherwise, it is a prime. So answer is both the statements are true. ठीक है ना? Integer valued divisor means we are talking about a factor. So the answer is both A and B are true. Any doubts to anyone? We have discussed in the beginning that if there is one factor between 1 to root n, then there is definitely other factor between root n to n. For example, if I take 36, 36 can be written as 1 into 36, 2 into 18, 3 into 12, 4 into 9, and 6 into 6. So you can see the square root of 36 is nothing but that is 6. So 6 से less अगर कोई factor है, तो definitely there is one factor which is more than 6. तभी उन दोनों को multiply करके 36 आएगा. So the answer is both A and B are true. Can I move to the next question? Please give me a response. Okay. So you can see the level of CAT. CAT में काफी questions आते हैं इस classification पे. These are very very small things, but CAT वाले काफी questions पूछते हैं. Now solve this question. Is the number 2 raised to power 58 plus 1 by 5 a prime number or a composite number? The number 2 raised to power 58 plus 1 by 5, is it a prime or a composite number? Achha, this is equal to 1. How can you say this is 1? Richard, 2 raised to power 58 plus 1 is a very very large number. You are not supposed to find out the remainder. Okay, चलो मैं बताता हूँ इसे करना क्या है. Now, this is 2 raised to power 29 plus 1 का square. क्या होता है? This is equal to 2 raised to power 58 plus 2 into 2 raised to power 29 into 1, 2ab plus 1. Alright. So from here you can see the value of 2 raised to power 58 plus 1 is what? I can say this implies that 2 raised to power 58 plus 1 is equal to 2 raised to power 29 plus 1 ka square minus 2 raised to power 30, which I can rewrite this as 2 raised to power 29 plus 1 का whole square minus 2 raised to power 15 और इसका भी whole square. Now this number is in the form of a square minus b square, and a square minus b square is always equal to a minus b into a plus b. So this will comes out to be 2 raised to power 29 plus 1 minus 2 raised to power 15 into 2 raised to power 29 plus 1 plus 2 raised to power 15, a minus b into a plus b. So this is the value of 2 raised to power 58 plus 1. Now can I say both the numbers will be definitely greater than 5? Yes or no? Tell me. 5 से तो बड़े ही होंगे ना, ठीक है, और 5 के मल्टीपल भी होंगे. So I can say this 2 raised to power 58 plus 1 by 5 is equal to 2 raised to power क्या आ गया 29 minus 2 raised to power 19 plus 1 by 5 into 2 raised to power 29 plus 1 plus 2 raised to power 15. So now this will be also a number which is always a composite number because it's a very large number divisible by 5. ठीक है ना? So this is a into b. Since it can be written as a product of two factors a into b, so it is definitely a composite number. It is not a prime. This is how we can prove whether any number is prime or composite. नहीं अभिमन्यु, remainder 0 आ रहा है doesn't mean it is a composite. Remainder 0 आ रहा है, it means that number is a multiple of 5. Remainder 0 आ रहा है, it means the number is a multiple of 5. No, Anusri, the question is what? You all are taking it differently. The question is not asking about the remainder. The question is simply 2 raised to power 58 plus 1 by 5. This is one natural number n. ये n prime है या composite है, not the remainder when it is divided by 5. Are you getting my point? 2 raised to power 58 plus 1 by 5 is a natural number, and you need to identify whether this natural number is a prime or composite. ठीक है? Siddharth is asking how will we strike this type of the questions in CAT? Any other shortcut? Siddharth, that's the reason you are attending the lecture, and I am discussing all the possible questions which can be framed on prime and composite. Rahul, that is the wrong approach. तुमने cyclicity यहाँ पे करना ही नहीं है ना, वो तो remainder तो find out ही नहीं करना है. Most of you are applying a wrong approach, but you are getting the answer. But try to understand. Here we do not need to apply the remainders or cyclicity, anything else. Yes. हाँ, उससे ये पता चल जाएगा this number is a natural number. That's it. But ये number prime है या composite है, ये कैसे identify करोगे? That is my question. Anupam, how do you identify by cyclicity? Tell me. Those who are saying that cyclicity. अभी मैं आ रहा हूँ उस पे हरीत. I'll come to your point also. Those who are asking, how can we say that it is divisible by 5? I'm coming to that point. हाँ, उससे क्या पता चलता है राहुल? We just know that this number is divisible by 5. That's it. But whether it is a prime or composite, how can you identify on the basis of cyclicity? That is my question. No, numerator is a multiple of 5. That's right. Numerator is a multiple of 5. I can say this number is 5a. What about a? A can be either prime or it can be composite. Are you getting my point? Cyclicity से कुछ नहीं पता चल रही है. Cyclicity से ये पता चल रही है कि numerator is 5 into a, that's it. 5 into small a upon 5, which is a. Now you need to tell me whether a is prime or composite. ठीक है ना? Anupam and everyone, is it clear now? Cyclicity यहाँ पे नहीं लगेगा. Yes, only divisibility can be checked. And now, some of you are asking the question, how can we say that this number is divisible by 5? Okay, that's right. That will tell you this number is divisible by 5. सिंपल सा फंडा है यार. मैं यहाँ पे अभी तक रिमाइंडर्स मैंने नहीं पढ़ाया है अभी तक. So I am not going to use the funda of the remainders, because once I will start with the remainders, then I will use the funda of remainders. Those who know the concept of remainders earlier, that is well and good. But those who do not know the concept of remainders, I'll go by very basic things. Just a minute. Give me 1 second. ठीक है ना? This is 2 raised to power 29. Divide कर लो यार 2 raised to power 29 को. क्या होगा? 2 raised to power 10 into 2 raised to power 10 into 2 raised to power 9 minus 2 raised to power 19 क्या होता है? 2 raised to power 10 into 2 raised to power 9 plus 1. 2 raised to power 10, 1024. And I think now you can divide it 1024 into 1024 into 512 minus 2 raised to power 10 is 1024 into 2 raised to power 9 is 512 plus 1. इसे 5 से डिवाइड करना है. आप डिवाइड कर दो इस नंबर को. 1024 को 5 से डिवाइड करो, -1 -1. So definitely we can easily prove that this is a divisible by 5. But it is not required actually here. Because if the question is asking it is a prime or composite, so definitely ये natural number ही होगा. 5 का multiple ही होगा numerator. Otherwise question पूछते ही क्यों? It can be a fraction also. Is it clear? Can I move to the next question? And as far as the remainder is concerned, do not worry. 5 घंटे का लेक्चर केवल रिमाइंडर्स पे ही होगा. 5 से 6 घंटे का. So उसमें बता दूंगा मैं कैसे डिवाइड करते हैं, कैसे फाइंड आउट करते हैं. Now let's move to question number 25. Solve this one, all of you. Now you know the method. What should be the approach for identifying whether the number is a prime or a composite number? Now I think you all know कैसे prove करते हैं. Same funda. If you are able to write down this as a product of two numbers, I can say this is 5 raised to power what? सबका आ रहा है composite ये? No. Okay, the question is 5 raised to power 12 plus 2 raised to power 10. Is this number a prime or a composite number? Yes, exactly the same way. Exactly the same way. एक मिनट, ये कुछ चीजें बंद करनी थी इसमें. Just a minute. Yes. Now 5 raised to power plus 2 raised to power 10, is it a prime or composite? So we can prove it similarly जैसे previous question में किया था. I can say that is 5 raised to power 6 plus 2 raised to power 5 का whole square. That is 5 raised to power 12 plus 2 raised to power 10 plus 2ab. That is 2 into 5 का power 6 into 2 का power 5. Alright. Now, so this will be comes out to be 5 raised to power 6 plus 2 raised to power 5 का whole square minus. Now remember this value. This value is what? This value is actually 10 raised to power 6 is equal to 5 raised to power 12 plus 2 raised to power 10. Now this 10 raised to power 6, it can be written as 5 raised to power 6 plus 2 raised to power 5 का whole square minus 10 raised to power 3 का whole square. Now a square minus b square is a minus b into a plus b. So 5 raised to power 6 plus 2 raised to power 5 minus 10 cube into 5 raised to power 6 plus 2 raised to power 5 minus 10 cube. So this is a product of two numbers a into b. So this is a composite number. Is it clear now? Subham, Abhimanyu, the same method which I had used for the previous question. Writing it as a product of two numbers. Okay. So can we move ahead to next slide? Great. Solve question number 26 now. है अभी meaning at least 5 questions. The class will go on till 11 o'clock to school. Half an hour more. Then all of you. Should I discuss this question? Tell me yes or no. Alright. चलो देखते हैं इसे. Now, y can be easily proved that y is a composite number. Am I right? Y can be easily proved that y is a composite number. ठीक है ना? y को पहले देखते हैं. y is 16 raised to power 8 minus 16 raised to power 5 minus 16 cube minus 1. ठीक है? तो here 16 raised to power 8 minus 16 raised to power 5 में से ये दोनों टर्म एक साथ ले लो और ये दोनों एक साथ ले लो. So this will be equal to 16 raised to power 8 minus 1 minus, I'll get 6 minus 1, sorry, minus 16 raised to power 5 minus 16 cube, sorry, plus 16 cube. So I can say this is a cube minus b cube. I can rewrite this number as 16 square of all cube minus 1 cube. Alright, minus 16 cube is common and then 16 square minus 1. Sorry, 16 square plus 1. Now this number is nothing but this is a cube minus b cube. We all know a minus b into something. ऐसा ही होता है ना? A minus b into something. So I am sure that you can do it after this. Factorize करके हो जाएगा? Tell me yes or no, or should I need to factorize it all? It is the composite number. You can prove it. कर लोगे ना? Problem is with the first one, x. Y, so definitely we can prove it. Y is the composite number. Alright. So I'm sure you all can prove that Y is the composite number. So I'm not going to discuss it in detail. Factor leke, common leke, you can find out. Now the important thing is how to identify whether x is a prime or a composite number. Now, so let me write down here a few things here. X is in the form of n raised to power 5 plus n raised to power 4 plus 1, which is equal to, I can rewrite this expression as n raised to power 5 plus n raised to power 4 plus n cube, alright, minus n cube. Remember n cube add कर रहा हूँ, n cube subtract कर रहा हूँ, plus n square minus n square, ठीक है, plus n minus n and plus 1. Alright, this is also n. Now, so I can rewrite further this equation as n raised to power 5 plus n raised to power 4 plus n raised to power 3 minus n cube minus n square minus n. ठीक है, n cube n square minus n, इन सारे टर्म को एक साथ लिख लिया और n square plus n plus 1 को एक साथ लेगा plus n square plus n plus 1. Alright, now just see here in this term n cube को बाहर ले लो, n cube into क्या आ जाएगा, n square plus n plus 1 minus n is common in these three terms, n is common, so I'll get n square plus n plus 1 and plus 1 into n square plus n plus 1. Now in all the three factors, n square plus n plus 1 is common here. You can see here that n square plus n plus 1 is common. So now take out n square plus n plus 1 outside here. So this will be comes out to be n square plus n plus 1 and into n cube minus n plus 1. So now since this number is a product of two factors a into b, so this is also a composite. Okay, so this is also a composite. So you can remember this as a standard result. This is the factorization of n raised to power 5 plus n raised to power 4 plus 1 is always equal to n square plus n plus 1 into n cube minus n plus 1. Rahul is asking how to get these ideas. Rahul, just simply by practice, mere practice, solving a variety of the questions and everything. And that's why I am here to help you all out. जितने भी possibilities बन सकती हैं वो सारे लेकर मैं आऊँगा. Do not worry. ठीक है. So that's why it is a composite. You can note down this formula also. क्योंकि मैंने इस लॉजिक के बेस्ड कई जगह क्वेश्चंस देखे हैं, तो ये पता होना चाहिए. I prove that. Okay, can we move to the next question? Answer is 4. X and Y both are composite. Alright, let's move to next question. Question number 27. Solve this. एक सेकेंड, दिस इज 243 into कितने जीरोज है? 1 2 3 4 5 6 7 8 9 10, ओके, into 10 raised to power 10 plus 81 into 10 raised to power 8 plus 1. This number is in this form. I hope that this is clear. 243 is 3 raised to power 5. So 3 raised to power 5 into 10 square का power 5 plus 3 raised to power 4 into 10 raised to power 4 10 square का power 4 plus 1. So this number is what? 300 raised to power 5 plus 300 raised to power 4 plus 1. और अभी डिस्कस किया था ना that this is a composite number in the previous question. Yes or no? We have discussed that thing. So the answer is it's a composite. मैंने बताया भी था कि ये previously discuss कर चुका हूँ. This is in the form of 300 raised to power 5 plus 300 raised to power 4 plus 1. So it's a composite. Alright, so I'm moving to the next. Another interesting question. I think that was the cat question. Next to पूछने जा रहा हूँ. Yes. It was asked in CAT 2004. Try to solve question number 28. This was asked in CAT 2004. Multiple of n into k. Not divisible by n means n का multiple नहीं है. So which means, am I audible? Just a minute. चेक करो एक बार फिर से. रिचा, अनुपम. Okay, ठीक है. Now, so what I was saying is that n minus 1 into n minus 2 till 3 into 2 into 1 is nothing but n minus 1 factorial. And it says that n minus 1 factorial is not divisible by n. This is only true for composite number, sorry, prime number. Why? Because prime number can never be written as a product of two numbers. You can start taking values. For example, if I say n is equal to 13, sorry, n equal to 12 भी लो. अगर 12 लूंगा तो ये क्या आएगा वैल्यू? I say 11 into 10 into 9 into 8 and so on till 3 2 into 1. But is it divisible by 12? Yes, क्योंकि बीच में 4 into 3 आएगा. 4 into 3 is 12. So it is a multiple of 12. Remember, it is a multiple of 12. 12 into something. But what about if you take n equal to 13? But the moment you take prime number n equal to 13, you will get 12 into 11 into 10 into something till 1. But is it a multiple of 13? 13 into something? No. Why? Because 13 can never be written as a product of two factors. So 13 से less जितने भी composite या prime number है, उनको मल्टीप्लाई करके कभी भी 13 नहीं आएगा. So this is not a multiple of 13. But if you take n equal to 14, so remember you'll get 13 into 12 and so on. बीच में 7 भी आएगा, 2 भी आएगा. So this number is definitely a multiple of 14. So the answer is that basically you need to count all the prime numbers. It will get satisfied only by the prime numbers. So count how many prime numbers are there between 12 to 40. There are 7 prime numbers, that is 13, 17, 19, then I think 23, 25, 27, 29 is there, and 31 is there, and 37 is there. So answer is option 2, 7. Is it clear to all of you? Tell me yes or no. Try to solve question number 29, all of you. Am I audible? Rahul, Anusri, Anupam? Okay. ठीक है, बीच में कुछ नेट प्रॉब्लम आ जाती होगी. That's not an issue. What is the answer of question number 29? All of you, please tell me what is the answer of question number 29. Okay, count all the prime numbers. The prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, then 23, 29, 31, 37. कितने prime numbers आ गए? 12 prime numbers. Now, but the answer is not 12. Now, there is an exception. Previous question CAT का था और ये question CAT में नहीं आया है, but एक और पेपर था उसमें आया है. IIMS कहीं, IIMS में एक अलग टेस्ट भी होता है किसी एक पर्टिकुलर कोर्स के लिए, उसमें आया था. Now the question here is, remember the important thing here is, यही है ना, n-1 into n-2 till 3 into 2 into 1. Now take n equal to 4. If you take n equal to 4, what will you get? You will get 3 into 2 into 1. Now, is it divisible by 4? Tell me. Is 3 into 2 into 1 divisible by 4? Tell me yes or no. No. So 4 is also satisfying this condition. Okay? So there is only one exception. There is only one composite number which will satisfy this condition. Previous question में range 12 से start थी, इसलिए वहाँ पे ये matter नहीं करता है. So always remember that n-1 factorial is not divisible by n. Not divisible by n. ठीक है? This implies that n is all prime number. It means only prime number will satisfy this condition. All prime number plus 4 also. This is the only exception, that 4 will also satisfy this condition. Is that clear now? Please tell me. So answer is 13, option 3. So if n-1 factorial is not divisible by n, all the prime numbers plus 4 will also satisfy. Rahul, 1 is not divisible by 2, that is true. ठीक है, 2 तो ऑलरेडी आ चुका है ना प्राइम में. Okay. So I'm moving to next question. Question number 30. Another interesting question. That 2011 का. This was asked in that 2011. नहीं रीचा, इसके बाद एक क्वेश्चन और है. ओके चलो देखते हैं. 741 A741. A741 means what? A741 means I'll write down 11111 741 times. ठीक है ना? 741 times. So add all of them. Sum of the digit is what? Sum of the digit 1 plus 1 plus 1. 1 को ये 741 times add करोगे 741 आ जाएगा, which is divisible by 3. So which means A741 is divisible by 3. And since it is divisible by 3, so it cannot be a prime. So first statement is true that A741 is not a prime. Is this clear, Anupam? Is it clear to everyone that sum of the digits in A741 is 741, which is a multiple of 3. Similarly, option 2, 534. A534, so 1 को 534 times add करोगे, so 534 is also divisible by 3. So second is also divisible by 3. So second is also true, not a prime. Similarly, A123, 123. 123 is also divisible by 3, 41. So this is also not a prime. ठीक है, it is also. So option से करोगे तो 1, 2 and 3, all the 3 statements are correct. So the answer is option 4. ठीक है, फोर्थ चेक करने की जरूरत ही नहीं है. हरीत, ये कहाँ लिखा हुआ है? ये कहीं नहीं लिखा हुआ है हरीत. इसी के बेसिस पे हम आइडेंटिफाई करते हैं. व्हाट इज द डिविजिबिलिटी रूल ऑफ 3? टेल मी. Divisibility rule of 3 is that if the sum of the digits is divisible by 3, the number is divisible by 3. 3. Yes or no, Harit? So अगर मुझे चेक करना है कि 111 प्राइम है या कंपोजिट, तो मैं ये बोल सकता हूँ ना, sum of the digit is 3, so it is divisible by 3. Similarly, A741, a sum of the digit is divisible by 3. Sum of the digit is divisible by 3, so it means it is a prime number. Sorry, it is a composite number. Is it clear to all of you? I discuss the fourth option. Option से करोगे तो fourth आ गया. But now how to identify whether A77 is a prime or not? Now, just hear all of you. That's a very important thing. A77, अब मैं इसको ऐसे लिख सकता हूँ. Remember one thing. You all know. What is 1? 1 is 10 raised to power 9. Sorry. 1 is 10 minus 1 by 9. What is 11? 11 is 10 square minus 1 by 9. What is triple 11? Triple 1 is 10 cube minus 1 by 9. 10 cube minus 1 is 999. 999 by 9 is 4. So on the similar logic, I can say A77 is equal to nothing but that is 10 raised to power 77 minus 1 by 9, which is equal to 10 raised to power 7 का power 11 minus 1 का power 11 by 9. And I am sure कुछ लोगों को पता होगा भी होगा. I think most of you will know that a raised to power n minus b raised to power n is always equal to, that will do in binomial theorem, a minus b into a raised to power n plus 1 plus dash 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 till b raised to power n. Factorization होता है ना? Tell me yes or no. That's a formula. So on the basis of this, I can say this number is 10 raised to power 7 minus 1 into, all right, a raised to power a minus b into a plus b into something. ठीक है? By 9. So 10 raised to power 7 minus 1 by 9. Now 10 raised to power 7 minus 1 by 9 is equal to what? 6 times 1 into something. So since it can be written as a product of two numbers, so it is a composite number. And I think you all have got an idea why I was focusing too much on prime and composite, because this was that 2011 question. What are the different approaches to identify whether the number is prime or composite? Is it clear now? So hence proved that this number is not a prime. Rahul, Shreya and everyone. Okay. Also at the same time, remember, can I delete everything from the whiteboard? लिख लिया है तो अगर तुम नहीं है सॉल्व इट फॉर. ठीक है. So I'm deleting everything now. Okay. Which step? Khushbu? 1 is 10 minus 1 by 9. 11 is 10 square minus 1 by 9. Triple 1 is 10 cube minus 1 by 9. Similarly, A77 is 10 raised to power 77 minus 1 by 9, which is 10 raised to power 7 ka power 11 minus 1 ka power 11 by 9. Now, we know this formula. A raised to power n minus b raised to power n is always a minus b into something. So I have applied that formula. By using this, I can rewrite this in this form. 10 raised to power 7 minus 1 into something upon 9. And 10 raised to power 7 minus 1 by 9 is 6 times 1. Is that clear now, Khushbu? Can I move? Yes, kind of. क्या doubt क्या है इसमें बताओ अभी भी. Okay. Another important thing which I'd like to discuss. नहीं आया? क्या चीज नहीं आया, Khushbu? Which point you didn't understand? Tell me. Which point? I'll explain it again. अगर कुछ नहीं आया तो. Okay. Great. और I'm just try to focus on now what I'm trying to say. अब देखो, एक और मेथड बता रहा हूँ इसके लिए. दूसरा मेथड इस तरह के क्वेश्चंस के लिए. Now remember 6 times 1. It is 6 times 1. So basically 6 is equal to 2 into 3. ठीक है ना? 6 is equal to 2 into 3. So you can rewrite this number as 11. 2 ones into 0 1 0 1 0 1 0 1 0 1 0 1 के 3 पेयर बनाओ. इनको मल्टीप्लाई करोगे ये 6 times 1 आएगा. Similarly, for example, if there are 15 ones, 1 1 1 1 1 15 times है. Alright, 15 times hai. So in that case, 15 is what? Remember, 15 is equal to 5 into 3. 15 is 5 into 3. So if I can rewrite this number as this is equal to 5 times 1. Just a minute. 3 times 1 5 3 are 15. It depends कैसे लिखते हो. 3 times 1 into yes 0 0 1 के 5 पेयर बना लो. 0 0 1 0 0 1 0 0 1 0 0 1. If you multiply this, you'll get 15 times 1. All right. No, Sanket, I'm not writing that. Product of co-primes नहीं लिख रहा हूँ मैं. This is just I'm telling one of the method how to factorize the sake of the number. Okay. For example, ऐसे कोई भी number हो, you can write down. So like here is 77 times है ना? 77 times 1 है. 77 times. 77 is 7 into 11. ठीक है, 77 is 7 into 11. So I can write down 7 times 1, 3 plus 2 5. 7 times 1 into 0 0 0 0 0 0 1 and then 0 0 0 0 0 1 and so on. 0 0 0 0 0 0 ऐसे 11 टाइम. वो बेसिकली जो फैक्टराइजेशन मैंने लास्ट प्रीवियस मेथड में जो फैक्टराइजेशन किया था ना, वो ब्रैकेट वाला पार्ट ये होगा एक्चुअली. Is it clear to all of you now how to factorize any number in which all the digits are same? You can factorize in this fashion. Okay, great, very good. Now, generalized. This was asked in ZAT 2005. 11. I remember ये 5 नंबर का क्वेश्चन था. उस साल ZAT में ना few questions are for 1 marker, 2 marker, 3 marker, 4 marker, 5 marker. Maximum 5 marker था. So this question was in another 5 mark category. Okay. हाँ अनुपम इसका generalized way. Now another thing, the last thing which I like to discuss today is before finishing this one. Another interesting thing. Easy है ये, ऐसा कुछ नहीं है. Now another interesting thing is n square plus n plus 11. ठीक है. Let's put n equal to 10. देखते हैं n equal to 10 पे क्या आता है. n equal to 10 पे आएगा 10 square plus 10 plus 11. What is this value? 10 square is 100. 100 and okay. What is 10 square plus 10 plus 11? Can anyone tell me? 110 plus 11 is what? 121. ठीक है. 121. It's a composite number. ठीक है. It's not a prime. But if you substitute n equal to 9, you'll get 9 square plus 9 plus 11. 9 square is 81. 81 plus 9. 81 plus 9 is 90. This is 101, which is a prime number. Remember, this is a prime number. If you put n equal to 8, I'll get 8 square plus 8 plus 11. All right, 8 square is 64. 64 plus 8 is 64 plus 8 is 72 plus 11 is 83, which is a prime number. Put n equal to 7. You'll get 7 square plus 7 plus 11. 7 square is 49. 49 plus 150 plus 60. This is 67, which is a prime. And so on till n equal to minus 9. Even if you substitute n equal to minus 9, you'll get minus 9 that square plus 9. Sorry, minus 9 plus 11. ठीक है. What is 81 plus 11? 81, 10, 91, 92, 92 में से 9, 83 आ जाएगा, which is also a prime. Okay. So what is happening in this case here? That if you put in this series for all the values of n which is lying in the range minus 9 to plus 9, this will be always a prime. If in this particular formula n square plus, or you can note it down, that n square plus n plus 11 is always prime for all the values from minus 9 to plus 9. I think minus 10 भी satisfy करता है. Minus 10 का square minus 10 plus 11, which is 100 plus 11 is 111. Yes, 101. Yes. So minus 10 से range. So you can note it down. That's a very interesting thing. I do not know कब किस फॉर्म में पूछ ले कभी किसी एग्जाम में, but you can note it down. ऐसे तीन चीज है, मैं तीनों that n square plus n plus 11. This is always prime for all the values of n in the range minus 10 to 9. N square plus n plus 17. This is also always prime for all the values of n from minus 16 to 15. Similarly, n square plus n plus 41. This is also prime for all the values of n from minus 40 to 39. So ये तीन चीजें याद रखना. That's a very standard result. ठीक है. These are always prime in this particular range. Is that clear? All right. Okay, guys. So we'll end the session today now. So with this, the prime and composite number concept is I am sure सबका फंडा बिल्कुल क्लियर हो गया होगा and you will not face any problem related with this. Okay. Now, if you have any doubts, you can discuss with me before ending the session. Now we'll meet again on Wednesday with the next session of number system. हाँ, वो मैं कराऊंगा अजय. Okay, next time the session will start at 9:30 instead of 9 because a lot of people are expecting saying that ऑफिस से आते आते थोड़ा लेट हो जाता है घर पहुंचते पहुंचते. So it's better to shift to 9:30. No, Rahul, it is only true for 11, 17 and 41, not for any other values of k. Only for 11, 17 and 41, not for any other values of k. Okay, yes, next session on Friday at 9:30. और आई थिंक इन द फर्स्ट सेशन में कुछ लोगों का हाफ एन आवर का मिस हो गया था और वो हाफ एन आवर की रिकॉर्डिंग भी अवेलेबल नहीं है. सो हाफ एन आवर का रिकॉर्डिंग में ना 9 o'clock पे और मे बी उसी दिन 8:30 to 9:30 मैं करा दूंगा. अजय और हरी शायद तुम दोनों का हाफ एन आवर का लेक्चर मिस हो गया था फर्स्ट लेक्चर. ठीक है, तो मैं फ्राइडे को 8:30 to 9 o'clock कर दूंगा, फिर 9:30 से ये अपना स्टार्ट कर देंगे. ठीक है. Okay, guys. Good night to all of you. In case if you have doubt, you can ask me again. संचित मैं बताऊंगा बाद में. ठीक है. You get an access to recording, तुम वहां से कर सकते हो, बट क्वेश्चंस तो साथ में साथ लिख लिया करो. So I'm ending the session because I think no one has any doubts. So मैं सेशन अब बंद कर रहा हूँ. Okay.